Hi folks, it's Dave
and Ben,
and welcome to another Fuze tutorial video. So good to have you here, so good to see you again. Hope you're okay, hope you're just doing absolutely swell. Never said the word swell before in that context, but there it is. Hope you're doing swell, hope you are staying indoors, hope you're nice and safe, playing games, and that you're warm-ish, lukewarm. So with that out of the way, it's good to see you again, and we are back with our much anticipated, long anticipated, many times promised vectors tutorial. This is one I've been excited to get to for quite a while, because as soon as we introduce this concept and we get it out of the way, we can move on to some really cool stuff, and we've got some things planned coming up that we are excited to bring you. So, vectors. What's going on, Ben?
We're doing vectory things.
They are vectory.
What's a vector?
You tell us. We'll wait.
Yeah, so...
Get in touch. See you in the next video. Like, share, comment, subscribe. Check out the Fuze Arena. All that stuff. Links in the description below. And see you no. Although, do all that stuff.
Do all that stuff.
Please do all that stuff. Keep the comments coming, guys. It is absolutely awesome to see you engage with us and in our videos. We love reading the comments. And yeah, so please do all that stuff. But we are here to tell you what vectors are. Now, this topic goes quite deep. And really, if you are totally comfortable with vectors, and I know that there are a lot of people out there who are, Gothon, I'm looking at you, mate. There are some people making programs in Fuze who are just using vectors to their full potential. Vectors are incredibly valuable and useful tools for maths. And obviously, because as an extension of that, for coding as well. They allow you to do some genuinely just incredibly magical things. But we are just going to introduce them as if you've never even heard of what one is before. We're not going to use them in their most proper and correct mathematical application, because I find that it gets in the way.
Mm-hmm.
You know, if you've been introduced to vectors at school before, perhaps in your you do it for GCSE, I think.
Yeah.
You do a bit of it. I mean, I remember my lessons at GCSE, and I remember going into vectors and just never understanding it. Just thinking, what are you talking about? In code, and especially in Fuze, you can get used to them in a really nice and simple environment before you then start to look at, there's this whole other layer of stuff that you can do with them that is just outrageous. You use them in all aspects of like a physics engine. You'll be using them a lot if you're going to make something like a physics engine where you want two things to bounce off each other and collide. You know, if you want one snooker ball to hit another, and you want this one to just hit the edge of this one so it gets knocked off and it spins, all of that is possible with vectors in an awesomely beautiful and simple way. But you have to get to grips with the basics. Right? I've talked plenty now, as usual. So let's just go into a project and just look at what is even going on. What is a vector? I'm a bit appalled to notice that we do not have a little title comment here. Vectors. We'll do that.
Vectors.
And we might as well use an 0 instead of the O there, because it's cool. It's just cool.
What about a 3?
Oh, good point, Ben.
No, it's in for the 0.
What? What are you talking about, then? Oh, vectors. Vectors! No! Let's just take out all the vowels and then everyone's happy. Right, okay, there's our title for the day. Vectors. So a vector is always going to look the same in Fuze in terms of what surrounds it. And that is a pair of curly brackets. If you ever see a pair of curly brackets in Fuze, you are actually using a vector. And you don't need to know all these amazing applications to understand what's going on. Most often, well, I say that, I've just immediately thought of a case where it's not. Most often, a vector is used as a coordinate. So if that's a position on screen, you could define that as an x, y vector, a two-dimensional vector. just like in your maths lessons, how you might see a coordinate that looks like this. Right.
That's 10 along, 5 up.
10 along, 5 up, or actually 5 down in the case of the screen. Yeah. But let's say you had this. Right. This is now a vector, and you could use it as any number of things. I was going to say this is now a position vector. It doesn't have to be. Use it for a bunch of other things. But let's just make a little variable called position, and we'll make it there 10, 5. Get some lines of space underneath, and make sure everyone can see that. Nice and big text. There we go. So now that we've got this 10, 5 vector, we've got an x and a y component. Vectors have components. That word looks like this. No, it doesn't.
No, it doesn't.
It looks like this. Component. You've got an x component and a y component. And just to remind you, this is the x, and this is the y component of that vector. That's better. Nice and neat. Now we can actually access that just like we do with an array in multiple different ways, and it's very, very nice and easy to remember. Now that I've got my x and y, I can actually just type in position dot x, and this will give me the x component of my position vector. Yeah. So if I did print position dot x, update and sleep for 2 seconds, and maybe get a nice big text size as well just up here so it's out of the way. We'll do 100. There we go. And we run. I've got 10 point a bunch of zeros, right? So just the number 10. If I want the y component, lo and behold, there's the y, and it's 5. Now it doesn't stop there. There is actually more to it than just an x and a y. Dimensions, vectors are actually always in Fuze 4-dimensional. We're going into the 4th dimension. We've actually got Z and we've got W. Now, I'm not going to even talk about this guy here. We're not going to mention W because I'm not going to pretend that I understand 4-dimensional maths. Some people do. Luke does. to some extent, you know, none of us can perceive the 4th dimension, but it's there. And these, if we just leave them as undefined, like we do here, they're just 0. They do exist though. If I print position.z, there's the 0, and position.w, there's that 0. I can add some numbers to these. I could say that that is 1 and that that is 3. And now I've got actual values in all of these vectors, in all of these components within my vector. Okay, so when you have seen in Fuze something like this, don't panic because you now know what it is. It's just an x and a y position. If you're using 3D, this will have a z-axis position as well, because we've already covered in our earlier videos the screen and how it is an x and a y-axis. But in 3D space, you'll notice that we're not all 2D flat objects, weirdly enough. You might have noticed that. Obviously, if you spend enough time looking at a screen on your computer, then you might think we're all 2D. But we're not. We're actually real 3D people in the world. And we have an x-axis, we've got a y-axis, and we've got a z-axis. Some of us, too much of a z-axis, if you know what I'm saying. That's a silly joke, that is. To be honest, it's y. It's all the x. All the axes. We've got x, y, and we've got z. Now, if we're in 2D, we don't need to worry about this z. If we're in 3D, we absolutely need that z for anything to make any sense. But let's just stick with this for now. We're not going to go into the 4th dimension. It gets weird at that point. But we'll just stick with this. So that's how you access a vector. Now, wouldn't it be weird though if I told you you can also access the x component of a vector with an R? Now what? What is going on now? What?
Well, now we leave it here.
Yeah.
See you later.
See you later. We'll be back in 48 months with part 2 of this, where we'll look at why it's a .r. So hold your breath until then. There you go. That was 48 months. We're back. Time just passed very, 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 very quickly in that 1.5 seconds. and we're going to explain what it
1.5
means.
seconds.
I think it's more than that, isn't it? It is now.
48.
Yeah, well, obviously 48 months, but 1.5 seconds to everyone else.
Ah.
We've been here. Let's stop this right in its tracks. What is that all talking about? Well, without even realising it, if you've been to a Fuze workshop before and you have done something like this, you have used a vector without even realising it. All of these words in green that are colours, so something like green or aqua isn't one, Dave. Cyan is one, or perhaps purple.
Or
yellow.
Or
Red.
Or
Fuse blue.
Or
Fuse pink.
Or
bisque. He thinks I didn't know where he was going with that. Bisque. If you've been to one of our workshops, you have typed the word bisque because I make everybody type the word bisque. If there's ever a colour to choose, it's bisque. And I've got everyone out there making these incredible bisque projects. We had somebody make some 2D game that was, it was actually 3D, that was just a bisque landscape with a slightly darker bisque floor with a slightly darker bisque object on there. And all you could see if you really squinted was something-ish, but it was just a bisque nightmare or dream, depending on your persuasion. So yeah, if you type the name of a colour, you've used a vector.
kind of.
I can, well, yeah, kind of. Secretly, you have. I can prove it. If I print blue, this is what Fuze will give me. That's a too big text size, too big on the text size. Let's go down a tad so you can see that. That's more. That's more. That's a bigger number. 160 is actually a bigger number than 100. In case you didn't know. I didn't mean to put 60. Let's run that. There we go. So here's our vector. Let's actually make it stay on screen for an amount of time that isn't just 0. We don't want this anymore. We want repeats. Right? There we go. So we've got our vector laid out here. So you've got a red, a green, a blue, and an alpha. Alpha is opacity. So whether or not
Alpha is Greek.
alpha is a Greek letter, that's true. I don't actually know why it's called alpha. But I always call it opacity because as the number goes lower, it's more see-through, more transparent, and as it gets higher, it's more opaque, less see-through. But the word for that is alpha.
Yeah, the Greeks came in and they were just like...
Yeah, they were just like...
And now we use alpha.
They were like, you're going to use this letter forever.
Yeah, for everything.
Everything. You know that whole system of letters that you use? We'll just name that. We'll name that. The Greeks echo forever in our lives, even now. They said, you know, those guys, Dave and Ben, when they do those Fuze YouTube videos. I mean, I don't even know what YouTube is, but I'm saying it as an ancient Greek person.
Yeah.
Yeah. They're going to use this word. So we'll name it alpha.
Mm-hmm.
Okay, right. We're confusing everybody now.
It's called alpha.
When we print blue, that's what we get. If we print any colour, you get the numeric values of their red, green, blue, and alpha channels. So if we print the glorious bisque, it's actually full red.
Full red.
I wouldn't have guessed that. 0.781751 amount of green and 0.560499 amount of blue.
You know what's going to happen now.
What's that?
I'm going to need to memorise that.
You've got to memorise that, Ben?
Yeah.
And you've got until now. 741651 and 6 something.
5, 6, something.
499 was the last bit. I think it was 7. Oh, I've forgotten it now. 781751 560499. We'll get there. We'll get there. Ben's the memoriser out of the both of us. Unless you're talking about card game rules, in which case I know too many of those.
And I don't know enough.
So, again, that's been derailed, and my train of thought is officially off the tracks. No.
By using colours, you've used vectors.
You've used vectors. Now you can access this in the exact same way as you would a vector, like position. And you can access position using R, G, and B, and A. So let's actually just put that W back in, just for the sake of it. Because you've also got R, G, B, and A. And you could do print position dot A to give us the fourth component of our vector, to give us the 1. We could do position dot B to give us the blue component. We could even use position as a colour. Right? We could even print the position blue channel in position, the colour. And it's not a very good colour because everything's over 1, so it's actually just white.
Position divided by 10.
Yeah, that'll give us something, right? There you go. Sort of the colour of sadness. That is. Yeah, it's not very nice, no. But
yeah, because there's 1 red, half green, half blue.
Yeah, so it's kind of it's almost brown, but like a murky sort of, more grey sort of colour. It's not very appealing in terms of ink colour. But if we put something in here like 1, 0, 1, this will give us a nice pink, magenta, full red, no green, full blue. That's our colour. Now all of the colours in Fuze are vectors. Okay, so you can print any colour in Fuze, see what the exact values are, and then you know what you're playing with, and you can access those. I could even do print bisc.r or bisc.g to access each component of bisc. Right?
And you could do it in bisc.g.
I could make the colour of my ink the green component of the bisc colour vector. It's going to just be green, right? Oh no, I can't do that, man. No. I can't do that.
You can kind of
I can't
play around with it.
I want 0 red, the amount of green that is in bisc, and I could do the amount of blue that is in red. Or pink dot blue.
Yeah.
With an alpha of 1.
Yeah, that's kind of.
That's absolutely ruin your brain. That's a lovely colour. It's like a nice sort of cyan. So, if this doesn't confuse you, it should, because we're presenting it in a very confusing way. But what you should remember is that this is how vectors appear in Fuze. Okay, you've just got some curly brackets, got some numbers in them. They can be accessed with X, Y, Z, W, or R, G, B, and A. Now let's say that you wanted to store something in a vector, and you didn't want to use it as a colour, and you didn't want to use it as a position, so it didn't really make sense to call it X, Y, Z, W, or R, G, B, and A, right? I wonder, maybe you could use it as, you could say data. Here's some generic data, my data. Good stuff. That's good. My data, and I want to just make sure that all these are nice and aligned. Right. And let's get rid of that. Actually, let's just go up here and just set that ink to bisc where it matters. And we're going to print my data. Now, I could be using this data for anything. I might not want to use it for anything that really makes any sense with .r, .y, .z, .b, or any of that stuff. You can actually access it like an array. You can do that, and it will give you the values. So if I do my data 1, we'll get a 0, and 2 will get a 1, and 3 will also give us a 1, because we're just printing the same stuff here. It's treated like an array as well. But when you get to that point, you have to be like, well, maybe I should just be using an array. You know, maybe my data should just be an array, and that would make some more sense. But I wanted to show you that just to show you that they're very versatile and that you can do all these sorts of things using vectors and access them in a variety of different ways. So hopefully this has dispelled a few of the fears of the old curly brackets, because I know that they can be heartbeat increases for some. When you see them, it's like, oh my word, I've got round brackets, I've got these brackets. You can even get absolutely ridiculous and put, I want to make a vector out of my data 1, my data 0.
My data 0, my data 1, my data 2, my data 3.
What, make it go
Yeah.
in order? That's just using the that's totally pointless. You
Yeah.
literally just use my data. Yeah, but you know, I just wanted to demonstrate that you could actually get into a situation that you've got these 3 sorts of brackets types all next to each other. And this is where you might find that spacing things out becomes a bit easier for you, maybe it doesn't get easier for you. I tend to not put spaces in vectors and put spaces in function brackets just to make things very different looking. So my vectors tend to look like this. Luke tends to do them like this. This is obviously, as we always say, up to you. There's no right or wrong way. Just do what comes naturally. Just don't put spaces in there, because no one does that. It's just ridiculous. Of course you can. You can do whatever you want with spaces. That is the beauty of it. So that is vectors at their most basic level possible. Okay, this is not even talking at all. Well, no, it's not.
It's a few layers.
Yeah, we've gone a couple of layers.
We've gone to the 4th dimension, but
yeah, it's basic 4th dimensional stuff, but we haven't really gone to the 4th dimension, because if you go to the 4th dimension with vectors, then you start to look at rotation matrices and all this mad stuff. And
rotation matrices are cool.
Yeah, that's
2x2. You have like what is it? Cosine, sine, minus sine, cosine. I think might be cosine minus sine, sine, cosine.
That could have been completely wrong, and I don't know. I'm going to be honest.
You can have well, obviously it would be like theta after that, and then that's how you do rotation with matrices.
Yeah. Show me a program, Ben.
You know what I mean.
Get a program.
You know if you know.
Yeah, you do know if you know. You know if you don't know. I certainly know that I don't know. Do you know? We'll see. No. No, I don't know. But I'm going to learn. You're going to teach me.
Okay.
In a minute.
Okay.
If you do understand vectors to their highest level, things just open up for you. You know, if you wanted to make a program where you simulate the flight path of birds, for example.
I just realised I was talking about matrix.
About the matrix.
A matrix.
And not matrices. Okay. Matrices is just the plural of a matrix, isn't it?
Yeah, I was talking about rotation matrix, not vector.
What? A matrix is just an array of vectors.
Kind of.
Luke told me that, so it's true. So I'm sitting
Kind
like
of.
this. Yeah, you can treat it as such. You can treat it as such. But without wanting to scare people away from the video, because people would have just gone, I'm out. You know what? I'm done. See you later. My biscuit is well and truly dissolved in the tea. It was like, rotation. What? Oh, I need to apply a 4-dimensional rotation matrix to get this biscuit to come back out of the tea, back in time, within the packet again. And there you go.
No, imagine that, using a rotation vector to just compile it together and just pull it out of the tea.
Easy stuff. Just need to rotate that biscuit back in time. You know, bring it back out of the tea, and then you could dunk. And then if you go slightly over, you just rotate the biscuit backwards in the 4th dimension.
Just slightly, and then you can get the perfect timing.
You could even keep oscillating back and forth so it stays at that perfect dunk moisture forever. Infinitely.
Forever?
Literally forever.
Even when you've eaten it?
Even after you've eaten it, long after. 4 days later, you just rotate it back out of your body and eat it again. This is where it's gone, Ben, in this conversation. Right, excellent. Let's just look at one little example program that uses a vector, and not in any sort of a serious, you have to use vectors to do this sort of way, but what's it called? Basic vectors. If you're working in 3D, which we will be very, very soon, I think probably in the next couple of videos we'll be looking at this, we'll be going over how to place an object in the world as a 3D object and how to move it around. And if you're using 3D, certain things have to be vectors. So for example, the scale of an object, which is this part here of this line, is a 3-dimensional vector with an x scale, a y scale, and a z scale, right? And you'll notice actually, because that leads, I forgot about this, but you see this little line here that says multiply by 2. This might be a bit confusing because you've got 3 numbers and you're multiplying it by 1 number. That's a bit odd. But since vectors are sort of multiple numbers being treated as the same thing, they're all one thing. If you multiply a vector by 2, you're actually multiplying each part of it by the number. So a vector of 1, 1, 1 times 2 becomes 2, 2, 2.
Yeah.
Nice and easy.
Isn't it?
Yeah. So I'm
treating that as one.
I mean, as you go into the higher levels of understanding vectors, that is the main part of understanding them. Is that, you know, you've got a vector which is a location on a screen, and that represents not just a location, but also a direction away from an origin point, a distance. Vectors have got magnitude, they've got length, and you need to understand these sorts of things if you want to create like a physics engine in 2D or in 3D or in 4D, apparently. But let's dial it back a little bit. And look at this. What is that I've just done? That's 4-dimensional right there. Let's dial it back a little bit and let's just go over this code here. We've got a loading of a model. We're loading in just an object made by the resident Fuze graphics artist Cat.
We'll go through this in a bit more detail
Also
later.
Yeah, we will.
Just briefly over this.
Yes, very, 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 very briefly. We haven't got long left on this video, I think. We've got a position vector for that ball. Really, this is actually the only point that you need to be focused on for this little video. This is where that ball is in 3D space. We are at 0 on the x-axis. Now, in 3D, it's a bit different than 2D, because 0 on the x-axis in 2D is over there, on the edge of the screen, 0 pixels. But in 3D, it's a bit different, isn't it? Because you don't have a screen, there's no sort of pixels. But if you're talking about 3D axes, you've got 0, which is in the middle. So you've got negative numbers, positive numbers. Then you've got 0 on the y-axis, and you've got positive numbers, negative numbers. And then you've got 0 on the z-axis, where you've got positive numbers. That's going to look really silly, what I just did. And then negative numbers coming back, right? So this is your 3D world space, and this is the position of that ball in that space. So this is actually smack bang in the middle of 3D space. If we run this, there's the ball. Awesome. There it is, in all of its glory, made by our resident artist Kat, who's also the editor of these videos. So shout out to Kat, thank you for the awesome work that you do, and for making us look even slightly less ridiculous than we do just naturally left to our own devices. If we want to change the position of this ball, this is the variable that we need to change. Changing this number will change its position on the x, position on the y, position on the z. Now, it's only going to work because we're using that vector, this variable here, our ball pos. We're actually using that here in this line called set object pos. I'm saying set this object that we've called ball, set it to the ball position that we've stored in this variable. Right? This could just be 0, 0, 0, and it will be exactly the same. Okay, so that will run exactly the same. So if we just replace it back with that variable, right, that's what we've got going on. Now, if I manually just edit this line here and we say we'll put 4 in the x component, we run it and the ball has moved this way, 4 units positive on the x-axis. We could do it to the y-axis, 2 goes up, and same on the z. Oh, fantastic use of the keyboard. If I put it at -10, it's going to be a lot smaller because it's shot off into the distance there. And yeah, it's gone quite far back. It's gone quite far back, hasn't it?
I think you're looking over your wrong shoulder.
Am I? Yeah, actually, I probably am because I always think that this is the middle of the screen, and it really isn't because we're bottom in the little corner. We're in the corner. There it is.
Over there.
I've got you now, you. Oh, good. Thanks, Ben, for making me look even more silly than I would make me look myself.
No responsibility for that.
No, you shouldn't. You shouldn't. There we go. Up in the distance it goes. Let's put it at 500. There we go. Get it gone. What's that? Help. Okay.
Nah. We're fine.
No, help you even more. No, sure.
Ooh.
Good. Okay, gone past us. There we go.
Whoa.
Now, I also added. It's never gonna get bored of this. I also added the ability to move this ball using the joysticks. So when you push on the joystick, and we've already covered this in the other tutorials, the exact same stuff applies in 3D. We're just changing an X, a Y, and a Z position, and we are adding to that position using the values on the Joy-Con joystick. Okay. And similarly, we could print any of these components. Just print ballpos.x.y.z. Probably worth looking at this little part here, because we've got this vector, this ballpos. Remember, this vector is... Let's just go back like that. This vector is 0, 0, 0. Okay.
Starts off as.
Starts off as.
Or does it anymore? Did you change it?
Yeah, I changed it to like -7 on here. So if we just put it 0, 0, 0, that makes that actually true. Okay. There we go. And we're adding to that, so we're redefining it with the plus equals. We're saying, right, take that and redefine it and add whatever values are in c.lx, c.ry, and the negative version of c.ly, and times that whole thing by 0.1 so it doesn't just go flying off into the distance. I mean, if I remove that, and I even just nudge this, right, it's going to start moving around quite quickly. It's actually not too bad. Oh, I've lost it. Back you go.
You've lost one.
I've lost the plot. I've lost the... It's like, here I am. Hello? Oh.
That looks like a flag.
It does.
Is that a country flag?
It's hard to get it back on screen. That is definitely not a flag. This would make a weird flag.
When the picture rotates.
It's so difficult to actually just move it gently. Oh, I can't. Let's leave that. So that's why I multiplied that by 0.1 so you actually can move it quite gently. And there you go. There's a flag for you. What flag is that? Bennsville.
Yeah, that's my flag.
The Republic of Bennsville.
I'm going to buy some land in Antarctica, which is actually illegal, I think.
Get some on the moon.
Yeah, I'm going to buy a
Can
planet.
you purchase land on the moon? Probably
I don't
can.
know.
I don't know. It's worth doing. So when we add a vector
Yeah, I'm
to
just
another vector,
going to the moon. Be back.
back in a minute.
Be back pronto.
Yeah. Cool. See you in a minute.
Yeah, see you in 10.
All right. See you in 10. Right. While Ben's on the moon, I'll explain this. Oh, good stuff. Good to see you again. Did you get some land?
Yep.
Excellent. I look forward to visiting. When you add a vector to another vector, you're adding each component to the components that you specify, right? So if this is 5, and this is 1, and this is 3, right? We're adding 5 to the X component of ballpos. We're adding 1 to the Y component of ballpos, and 3 to the Z component of the ballpos vector.
One problem with that.
What's that?
How are you managing to get 5 from LX?
Yeah, well, I know that's not happening yet. We'll find 0.2. At this point that it reads it, Ben, it could be, right? This really could be. But
it couldn't be 3 or 5.
It definitely couldn't be 3 or 5. I knew you were going to say that. And then when we multiply it all by 0.1, actually these will become 0.1% of...
Not 0.1%, 10%.
10%. 10%. 10%. 10%, Dave. It's been a long day.
10%.
Been a long day. 10%. Whew. That's it's been a long video. That's what it is. And I tell you, the trip to the moon and back takes it out of you. So hopefully this.
I was the one that went.
And if you've managed to discern any information from this video, despite our ramblings, I hope that this has cleared some stuff up for you with vectors. Don't be scared of them. It's just a pair of curly brackets at the end of the day. It's the same thing as a pair of coordinates. In most cases that we're going to use them. We might use them for scale, we might use them for colours, We're going to use them for position and for velocity as we move forward through these projects. But we didn't want to just go, bringing all this new stuff onto you without introducing it in some context first. I would honestly recommend that next time you're making a project, and it's even something like a ball bouncing around the screen, if it's just Pong, basically, that sort of thing, rather than using separate x and y variables, so like x pos equals 10, y pos equals, rather than using that, make just one and do this. And then use pos.x and pos.y in your commands. In a circle command, you could use, I want this circle at pos.x, pos.y. Right? Just try them out in simple situations first, get used to using them and using their components, and then look at, the next step. There are tutorials in the Fuze tutorials which use vectors in a much more complicated way. For example, the first-person camera really starts to use some of the more complex operations that you can do on vectors, like the dot and the cross product, but there's no need to introduce those in this video. Hopefully this doesn't scare you away and it makes you think, vectors, eh? I could take that on. Come on, bring it on, vectors. Because that's what that is the sort of attitude that you need to have with this stuff. With that attitude, you will learn a lot more than you think you will. And just, you're more than capable of doing it. So look things up online, use all the resources available to you, get educated on vectors, and we will see you again for another tutorial in which we are going to start looking at making a simple game in 3D. So I look forward very much to bringing you that. Thank you for staying around and watching the whole video. If you have, there's usually something at the end of the videos that Kat will edit in as a daft little moment that happened. Sometimes there's some silly editing, so do stay around until after that Fuze screen has gone if you want to see what the new me looking stupid moment is. And there's plenty of them. It's not like you're short of material there. Okay, guys, thank you so much for being with us. Like, share, comment, subscribe, all of that stuff. Join Fuze Arena. Link is in the description below. I think I'm not missing out anything there. Shout outs to all the Fuze team and everyone who makes this all possible, to our editor and our boss and our programmer and everyone in the community, to Mike, to Colin, to Martin, to all you guys, to all you brilliant programmers. Thanks so much, and I've been Dave.
And I've been Ben.
And I'll see you next time. No, I don't. No. But I'm going to learn. You're going to teach me.
Okay.
In a minute.
Okay. Do you want me to teach you matrix rotation then?
No.
Okay.